Alright, let's get started with 4-3. So in 4-2 we added and subtracted matrices. Now in 4-3 we're going to multiply matrices together. So matrix multiplication is what we're up to for 4-3. Alright, so there's two different types of matrix multiplication. There's scalar multiplication, and then there's multiplying two different matrices together. Alright, so three different phrases here. Scalar, scalar product, matrix multiplication. So be on the lookout for those three as we go through. Alright, so quickly see if you can do 1, 2, and 3 for me. Find the sum of these three matrix problems. Alright, so let's introduce what we mean by scalar. If we're taking a matrix and multiplying the whole thing by just one constant number, that number is called a scalar. Okay? So a scalar is just a regular real number that's multiplying, that's a factor of our matrix. So if we're going to multiply by the scalar, we have a scalar product. We're doing scalar multiplication. Alright? And the way we do that is we're just going to take every element of our matrix and times it by the scalar. So 3 times 3, we get 9. 5 times 3, we get 15. 3 times 2, 6, and 8 times 3, we get 24. Okay? Alright, so let's take a real world example. We want to take all of our prices here and times them by 1.5. So we're going to go 1.5 times, we can turn this into a matrix easily, just put the numbers here. So every single number gets times by 1.5. And the result would be these 6 numbers here. See if you can do the same thing. Do some scalar multiplication here for understanding check number 1. Alright, we can do scalar in more than one spot. So if we know that A and B are these matrices, we could do 5a minus 3b, which means order of operations. First we're going to go 5 times every number for A. We're going to go 3 times every number for B. Once we've done that, so 5 times 2 is 10, 5 times 3 is 15, 3 times 3 is 9. Then we're going to just do normal, just matrix subtraction. So 10 minus 9, and we get 1. Okay, we can tell that from the beginning. 5 times 2 is 10, minus 3 times 3, 10 minus 9 is 1. And we're going to do it all the way through. Alright, so your turn. Use these matrices, A and B, and solve these two problems. Okay, so again, just like in 4-2, in 4-3, anything that we can do with normal multiplication, we can do with scalar multiplication. Alright, so all of these properties are just properties of normal multiplication, and they hold true when we're doing scalar multiplication as well. Alright, so we can do something like this. Let's do solving. So same thing as before. Let's clean this one up first. 2 times 3 is 6, and then 8, negative 4, and 2. If we times the 2 all the way in, how would we get rid of this? We need to subtract it on the other side, so you can see that here. Move it to the other side. And then let's clean it up. What's 10 minus 6? We get 4. What's 0 minus 8? We get negative 8, right, all the way through. And so now we know what 4x is. Oh, we got to get rid of the 4. How would we do that? We're going to divide by 4, or times by 4. Same thing. Every number in here is going to get divided by 4. 4 divided by 4, we get 1. Negative 8 divided, we get negative 2, right? And so that's our answer. Now this is nice here. They say, could we check this going back in? Absolutely. Let's plug in our new matrix for x, clean it all up, and add them together, and they should be identical equal matrices, which they are. Your turn. See if you can do A and B. Clean these up. Alright, so there's an investigation here that I'd like you to take a minute and do. So go ahead and pause your video, take a look at this. This is in the book, or you can look at it on the screen. Read through these problems and see if you can answer all of these questions before we move on. Okay, we'll go over this in class, but make sure, give this a shot for me. Okay, multiplying matrices together. Now we're going to take two matrices and multiply this one times this one. The way that we do is we multiply each row of the first matrix by the columns of the second matrix. So you'll see here, rows by columns. Rows by columns. Here's how we're going to do it. The first row is negative 1 and 0. The first column is negative 3 and 5. We're going to multiply corresponding parts. So the first number times the first number. Negative 1 times negative 3 is 3, plus the second number, 0, right? 0 times the second number, 5. 0 times 5 is 0. Negative 1 times negative 3 is 3, so we just get 3. That's the new answer for the top left number of our multiplied matrix. If we wanted to know the bottom right, we would take the bottom row times the right column, corresponding numbers. 3 times 3 is 9, right here. Negative 4 times 0 is 0. Put them together, you get 9, so that's where the 9 comes from here. Okay? So this is a little tedious, and you got to go step by step through it, but see if you can do this for A here. Multiply this matrix times this matrix. And then B, just thinking, would we get the same answer if we reverse this and we did B times A? If we switch the order, okay, that's commutative. Can we switch the order and get the same result? Think about whether we can do that from what matrix multiplication. All right, so here's the definition of matrix multiplication, right? And so this is just kind of in words explaining what we just did. We can do this on word problems as well. We want to find how much money we make in the store if we sell tapes for 8, LPs for 6. Do you guys even know what LPs are? It's a good question. Or tapes. LPs are just records. CDs for 13. And here's how many we sold of them. We could multiply them all. 8 times 9, 6 times 30, 13 times 20. Add them up, we get $512. All right, so see if you can do the same thing. Multiply both matrices here. All right, so one thing to understand is that when you do matrix multiplication, you can take, if you got an m by n matrix to start, so this one is a 3 by 2 matrix. This one is a n by p. This is a 2 by 4. If you line these up, let me write this out. This one is a 3 by 2, and we're timesing it by a 2 times 4. To be able to multiply matrices together, the middle numbers have to match, and if they do, the result is a 3 by 4, the outside numbers, 3 by 4 matrix. So if I multiplied a 5 by 3 matrix times a 3 by 7 matrix, the resulting matrix would work. We could do it because the 3's match, and the result would be a 5 by 7 matrix. If I tried to do a 5 by 3 times a 5 by 3, wouldn't work because those numbers got to match. Couldn't do it. We would not be able to get matrix multiplication there. All right, so we see that here as well. Can we multiply these together? This is 3 by 2. Okay. This is 2 by 2. So can we do it? Yes. What's the result? 3 by 2. Can we go the other direction? Can we do h times g? So h times g is 2 by 2. G is 3 by 2. Can't do it. The middle numbers don't match up. We don't have a match. So see if you can figure out whether we're able to do r times s and able to do s times r, whether they're defined or undefined. And if we can do it, go ahead and multiply it all the way through and figure out what the result would be. All right, last section here, just kind of telling you everything here. These are the rules for matrix multiplication. Okay, A, B, and C are m by n matrices, so they're all the same size. If they're all the same size, we can reverse the order. The order's not going to matter. If any of the dimensions aren't exactly the same, you can't reverse the order. So that answers that question earlier of could you reverse the order and get the same thing. Only if we have square matrices, 5 by 5 or 10 by 10. And that's it for 4.3. So any questions, ask them in class, and we will definitely go over this again. Good luck.